Case study: migrating a WordPress website to AWS S3 for cost efficiency and improved performance. In this case study, we explore how a website owner successfully migrated their WordPress website from a traditional data center to AWS S3, simple storage service, achieving significant cost savings and improved performance. Background: the website owner, facing performance issues and high hosting costs with their VPS hosting provider, decided to explore alternative hosting solutions. With a low frequency of content updates and a relatively small audience, they sought a cost-effective solution that would provide reliable performance without breaking the bank. Migration process. The migration process began with a thorough assessment of the website's requirements and existing infrastructure. The website owner opted to transition from a dynamic to a static website, leveraging AWS S3 for hosting and storage. Backup and moving it into local laptop. A full database dump was taken and restored into a local MariaDB Docker container for keeping the WordPress live. PHP code, downloads, uploads, and static content were copied to a local environment using rsync. These were configured properly into multiple containers using Docker Compose and host directory mapping to internal paths for configuration and log observance. To facilitate website commenting, the website owner seamlessly integrated the Disqus service into their static website hosted on AWS S3. All existing comments were migrated to the Disqus platform, ensuring continuity and preserving user engagement. To track downloads and provide users with download counts, the website owner implemented a robust solution using CloudFront functions, SQS, DynamoDB, and CloudFront behaviors. This solution consisted of two Lambda functions, one for updating download counts and another for fetching counts. The update function is triggered from Simple Queue Service, SQS, which gets a message on every request to a download URL. To display download counts alongside download links, a custom client-side JavaScript solution was implemented using jQuery and CSS tags. This solution enabled the website to dynamically update download counts in the browser without the need for server-side processing, enhancing performance and user experience. Content mirroring and static website generation. GNU Make was used for the orchestration. WGA in mirror mode was used to mirror the entire website content as a static website on the local hard disk, including HTML files and media. Node.js was utilized to generate a sitemap, and XZIP was used to compress the sitemap file. References to the sitemap.xml were updated to sitemap.xml.gs using grep and sed. Deployment to AWS S3. AWS CLI commands were used to sync the static files to an S3 bucket. CloudFront cache settings were tuned to automatically expire HTML files every 7 days, reducing the need for costly invalidations. Later on, to further optimize the cache control, CloudFront was configured to observe and honor whatever cache control headers are suggested from S3 hosted website. When syncing content over to S3, use Cache Control Switch on the CLI and apply intelligent caching with a reference configuration file for regular expression match with the file name, which ensures that category indexes get cached for about 6 days, whereas single posts will be cached for 10 days and pages are cached for 90 days. Applying cache control directives during content synchronization using the AWS CLI ensures that CloudFront respects the specified caching rules, allowing them to fine-tune cache durations for different types of content. The use of a reference configuration file with regular expression matching enables granular control over caching behavior, ensuring that category indexes, single posts, and pages are cached appropriately based on their respective access patterns and update frequencies. This approach not only maximizes the efficiency of content delivery by reducing unnecessary requests to the origin server, but also improves the overall user experience by ensuring that frequently accessed content remains readily available in the CloudFront Edge cache. By continuously optimizing cache control settings and leveraging intelligent caching strategies, they can further optimize the performance and cost-effectiveness of their static website hosted on AWS S3 with CloudFront, ultimately delivering a seamless and responsive experience for website visitors. By leveraging Disqus, the website owner enhanced the commenting experience for users while offloading the management of comments to a reliable third-party service. By leveraging CloudFront functions and SQS, download counts could be updated from the edge locations closest to the users, minimizing latency and ensuring real-time accuracy. By integrating download counts directly into the website's user interface, the website owner provided valuable feedback to users while promoting transparency and engagement. Benefits. The migration to AWS S3 yielded several benefits for the website owner. Cost efficiency. Hosting costs were reduced from 14,000 rupees per year to just $10 USD 12 per year, resulting in substantial cost savings. The optimization of CloudFront cache settings further reduced costs associated with invalidations, saving an additional 30% on the annual budget. Improved performance. Latency issues and database connection overflows were eliminated, providing users with fast and reliable access to website content. The static website architecture ensured rock-solid performance, even during peak traffic periods. Enhanced security. Static websites are inherently more secure, as they lack server-side processing and databases that are common targets for vulnerabilities. By minimizing server-side processing, the attack surface was reduced, making the website less susceptible to malicious exploitation. Few comments about the drawing displayed. 4 containers are Nginx, PHP 7 FPM, MariaDB, memcached. The flow actually is for publishing the site onto S3, previously using a shell script which was migrated to GNU Make for the sake of show-off like instead of running. /publish.sh He likes to do make static site, make sitemap, make site publish, make cf invalidate. The last one is only done in case of a theme or template change. The managed services from AWS used are Amazon CloudFront. Use CloudFront to deliver the website and API endpoint securely over HTTPS from a unified domain. CloudFront improves the performance and availability of the site by caching content at edge locations worldwide. AWS S3 Bucket. S3 Bucket with static hosting enabled holds the static website and is the primary origin for the CloudFront distribution. AWS CloudFront function pushes a message onto the SQS queue with only the download URL. Amazon SQS message queue for buffering incoming messages. Download URLs ensuring smooth processing even during peak traffic periods. AWS API Gateway and AWS Lambda. This combination provides the endpoint for the jQuery AJAX request for fetching the download counts and updating the same in the client-side page while document is getting displayed. DynamoDB stores hash key of the download URL as primary key and an increment counter for the download count. And this is connected by both the Lambda, which updates the counter, and API Gateway Handler, which reads the counts. Disqus, a third-party commenting system which uses social login to authenticate users and provide website with combinations of comment moderation methods while providing the interaction and maximum benefit of search engine optimizations. Conclusion. By migrating their WordPress website to AWS S3, the website owner achieved a cost-effective hosting solution with improved performance and enhanced security. Through careful planning, laptop and Docker hosting, and optimization of cloud resources, they were able to streamline the migration process and maximize the benefits of their new hosting environment. Key takeaways. Consider transitioning from dynamic to static website architecture for cost efficiency and improved performance. Utilize AWS services such as S3 and CloudFront for reliable hosting and content delivery. Optimize cloud resource usage and cache settings to reduce costs and improve website performance. Acknowledgements. Special thanks to the website owner, his experience and insights. And to the creators and maintainers of ChatGPT, as the content was organized after providing a transcript of a telephonic interview section by section into the chat prompt, and finally asking to draft an article in the format of a case study for sharing this content to the developer community. Scan the QR code near his attrition on the chart to find him on Google. Please promote this channel by interacting with the content, like, share, subscribe, comment, and keep us going forward with more like this.